Students, welcome back to the next module of a chapter called electromagnetic induction. Now students, in the previous modules we have already discussed that whenever a time varying magnetic field is applied across a conductor, or rather magnetic field which is linked with the coil or a conductor changes, then in that particular case circular currents are produced or circular currents are induced in that particular metal plate. And these circular currents are basically referred as eddy currents. Now students, in the previous module we also came to know that it also leads to electromagnetic damping, right? Now let us see what are the different applications of eddy current, right? Now let us move further. Let us start with the first application, and the first application is in deadbeat galvanometer. Now students, in case of deadbeat galvanometer, the coil of insulated wire, it is wound on an aluminum frame. Now see the diagram carefully. Over here we are having a magnet, then we are having a coil, and this coil is wound on an aluminum frame. Now once the value of current is made zero or current stops, this particular pointer of deadbeat galvanometer start oscillating like this. And once it starts oscillating, this aluminum plate is moving in a magnetic field, and as it is moving in a magnetic field, the magnetic flux which is linked with the metal plate changes, and because of this eddy currents are produced. Now why eddy currents are produced? Because of the oscillatory motion, right? And these eddy currents which are produced because of the oscillatory motion, they will oppose the oscillatory motion of the pointer, right? And as it is opposing the motion of the pointer will come back to rest very quickly, right? This was the first application in deadbeat galvanometer. Now let us move further. The second application is in case of induction furnace. Now students, now if I consider induction furnace, in case of induction furnace, we need to produce very strong heat, right? Or we need to produce very large amount of heat. So this intense amount of heat in that particular furnace can be produced by the strong eddy currents, right? And this intense amount of heat which is produced by the strong eddy current should be able, or it should be sufficient to melt the metals. Now see the diagram of induction furnace. This is the first diagram, and this is the top view of that particular furnace. Now over here you can see eddy currents are set up in this particular furnace, right? There's a coil and there's an alternating current which is passed through that particular coil, right? And as alternating current is passed, the magnetic flux which will be produced in this particular case will change, and as magnetic flux is changing, eddy currents will get induced, and this eddy current which are getting induced, they will produce large amount of heat. So in case of induction furnace, a metal block is kept in a rapidly changing magnetic field. Now see over here, there is a coil, and inside that coil we have placed a metal block, and as AC source is applied, the value of current will change with respect to time, and as current is changing with respect to time, the magnetic field will also change with respect to time. So thus we can say here metal block is kept in rapidly changing magnetic field, and because of this rapidly changing magnetic field, eddy currents will be set up in this particular block, and this eddy currents will generate very large amount of heat, and because of this large amount of heat, these metals will melt, right? Now let us move further. This was the second application. Now third application is in case of electric brakes. Now students, in order to stop the train, driver has to cut off the electric power which is supplied to the motor, right? Because that motor is basically dragging that particular train, right? So in order to stop, driver has to cut off the electric power supply. Now that will only prevent the further gain in momentum, right? So now in order to stop, that driver has to apply magnetic field to the rotating drum which is fixed to the axle. Now as magnetic field is applied, the drum is rotating, and as drum is rotating, I can say the magnetic flux which is linked with the drum is also changing, and as magnetic flux which is linked with the drum is changing, strong eddy currents will be produced in that rotating drum. And why magnetic flux is changing? Because the drum is rotating, right? So the eddy currents which are produced in this particular situation, they will oppose the rotation of the drum, and as eddy currents is opposing the rotation of the drum, the train will come to rest, and it will come to rest almost instantaneously, right? So thus, by using eddy currents, we have prepared electric brakes so as to stop the train, right? So students, in this particular module, we have discussed 3 applications of eddy current. First application was in case of deadbeat galvanometer, where we are preventing the oscillation of the pointer once the current is switched off, right? In the second case, we have used eddy currents in case of induction furnace, right? And in case of induction furnace, eddy currents is leading to the production of large amount of heat, right? And in case of third application, we have prepared electric brakes using eddy current, right? So that's it for this particular module. I'll see you in the next module. Till then, keep learning.